In this video, we're going to talk about the definition of a function. We're going to define relation, domain, and range. A relation is a set of ordered pairs. Typically, we're talking about x and y for an ordered pair. X is the input of the function, and y is the output of the function. With domain of the relation, it is a set of all the first components of the ordered pairs, known as the x values. The range of the relation is the set of all second components of the ordered pair, known as the y values. So we're going to explore some different ways that these components, or domain and range, can be given to us. One way that we can be given information is in a table of values. So we're going to consider the information that's given in the table. Notice we have x, that's the first component, and f of x is the second component. F of x is also known as our variable y. So if we're looking for input values, we're simply making a list of all the values that x could assume. So looking at the table, we have -2, -1, 0, and 2. So we're simply making a list of those input values. I'll separate those all with a comma. So that's how you would list the input values. As far as domain is concerned, domain is going to list our input values from the smallest to the largest value. If any of those input values repeat, we only need to write them one time. So it looks like the input values already are in order from the smallest to the largest. And notice set brackets are used here to list this domain because it is a specific set of numbers. Only -2, -1, 0, and 2 will be used for the input values. So that's why we're using set brackets to show this is the set of input. For output values, we go to the other column, our f of x or the y column, and we can see we have 4, 1, 2, and 4. So to list the output values, I'm listing 4, 1, 2, and 4 because there were 4 values given. But when I write that in the format for range, remember, since I see 4 is repeated, I don't need to write that twice. I also want to write the range from the smallest to the largest values. So I would begin with 1, 2, 4. And it's in set brackets because only this set of numbers is the output. Now it's important to note that set brackets are used because not every number between the smallest and the largest value is included in the domain or range. Rather, the given values are the only members of the set. Another way to determine the domain and range of a relation is to look at a graph. So we have a graph here about small town teens with cell phones, and there are some numerical values on each axis. We've got age in years for the input or x-axis, and then we have number of teens for the y-axis. If we are trying to determine domain, remember that involves the x values or the input. So looking at the graph and the x-axis, I can see the smallest value is 13, and that corresponds to this first dot on the graph. And then we move along the graph and it stops right here. So the corresponding x value there is 19. So anywhere between 13 and 19, we would expect to see this graph. So the domain, remember, describes x values. It includes 13, it includes 19, so I'm going to use the brackets. This also implies that every value in between 13 and 19 is included in the domain. So if you think of a number between 13 and 19, say 17. We go to the graph, there's 17. Follow that up. Sure enough, we're going to find our relation corresponding to an x value of 17. So anything in between 13 and 19 and including those endpoints are part of the domain. For the range, remember, that is concerned with y values. So the y values have to do with the number of teens. Well, on our graph, I can see that the lowest y value is right here at 229. And when I follow this graph from left to right, here's the highest value. So remember, that corresponds to a y value. And here, the y value is going to be just over 200, but we know it's exactly 229 because it's given on the graph. And for this highest value for y, you can see that it's between 600 and 700, but it tells us it is 642. So again, range will include those endpoints, so we use brackets. The lowest value is written first, 229, and then the largest value of 642 with a bracket will be the highest value for our range. So just be sure that you're always writing these in order from the smallest to the largest values. Next, we're going to consider the graph of f of x. We're going to use interval notation to determine the domain and range. Domain, again, would be our x values. So you can see where the x-axis is. One thing that you need to pay attention to with your line is that this line has arrows on each end. That means the line continues in both directions. So don't think that it stops at 7. It doesn't. This line is actually continuing indefinitely. And the same at the other end of the line. It's going to continue indefinitely going to the left. So what kind of numbers does that involve? If I go continuously to the left, that's negative infinity on the x-axis. If I go continuously to the right, that's positive infinity. So domain related to x values means we have no stopping point. This line continues in both directions indefinitely. So that would be from negative infinity to positive infinity. And notice now we're using a parenthesis. The parenthesis means that you do not have a stopping point. It continues. For the range, we're looking at y values, or f of x, if it's written with function notation. So considering the values for y, if we look at the smallest values of y, those would be below the x-axis. These are where y assumes a negative value. And we can see that our line is going to fall down here, and it continues down forever, right? So those values of y go to negative infinity. When we consider positive y values, that's everything here above the x-axis. Again, this line is continuing forever, and that would be to positive infinity for the y values. So you'll notice with this particular line that the range and the domain are both the same. The only time we would not have the same domain and range for straight lines is if we're dealing with special cases of vertical or horizontal lines. Now we're going to determine whether the relations are also functions. We are going to use the vertical line test. If no vertical line can be drawn so that it intersects a graph more than once, the graph is a graph of a function. We're going to state the domain and range of each relation group. So you can see in the first picture we've got a circle, and a vertical line has already been drawn. Do you notice how this vertical line intersects our circle in two different places at the same time? So that means it is not a function. To state the domain of this relation, then, if it's not a function, then it can only be called a relation. The domain is going to be describing the possible x values. So you can see that we pretty much have a boundary on the left and right side of the circle. So going from our origin, I would go 3 units to the left, so that would be an x value of -3, and to the right it is also 3 units, so that would be +3 units. So the domain would be values from -3 to positive 3 with brackets because the circle would include those values of negative 3 and positive 3. The range is going to be described by the y values. So I'm going to just sketch some boundary lines here and then count. How low does the circle go on the y-axis? 1, 2, 3 below the x-axis. That's negative 3, and it goes 1, 2, 3, positive 3 units on the y. So it looks like the domain and range are exactly the same because this circle was centered from the origin. In the next example, we've got a parabola that's drawn opening to the right, and here's our vertical line. We can see that the vertical line is intersecting this parabola in 2 places at the same time. So this is not a function, it is just a relation. To determine the domain of this relation, I'm going to look for possible x values. Again, when we're writing interval notation, we need to start with the smallest and then the largest value. So domain deals with x values. I can see that this parabola does not go on the negative side of x. Its smallest value of x is right here at the origin. So it would be equal to 0. And as we head to the right-hand side, or where x values are positive numbers, that would be on this side, notice that there are arrows. That means this parabola is actually continuing to the right, and that is positive infinity. What this tells us is that x values can be as small as 0 and including 0, and go to infinity with a parenthesis because it would not stop. It would continue going to the right. In our next example, we have a parabola that's opening upwards. Our vertical line is drawn, and this time notice that there's only one point of intersection. So we do have a function. To determine the domain of our function, we're looking for the x values. So notice the negative values. On this side of the axis, we have negative values, and there's an arrow. So that means it's going forever to the left. So as this parabola opens wider and wider, it will go to negative infinity. And to the right of the axis, this is where x values are positive. Again, we've got this arrow, so it means the parabola is opening wider and wider to positive infinity. So the domain would be from negative infinity to positive infinity. So any x value, any real number for x, is the domain. For the range, we need to look at y values. Starting with the smallest values for y, that would be the negative values. Is our parabola anywhere in this yellow shaded region? No. So the smallest y value looks like it's sitting right here at the origin. That would be equal to 0, so we use a bracket. Then we'll look at the positive values for y. And we do have our parabola there. And notice that there are arrows on both ends. That means it's going up forever to positive infinity. So the range must be from a smallest value of 0 and equal to 0 to positive infinity. In our last example, we are given this straight line. Here's the vertical line test. Again, we can see we have only one point of intersection. So there's no repeated x values. Every x value is paired only with one y value. So that makes this a function. To determine the domain, we're looking at x values. So on the negative side, we can see that we have an arrow. This line is continuing forever to the left. That's negative infinity. So the domain is starting with negative infinity. On the right-hand side, again, we have an arrow going to the right, never stopping. That would be positive infinity. When we consider the range, negative values for y, we have a line with negative values for y. Again, the arrow tells us it's going down forever, so that would also be negative infinity. And for the positive values of y, we do have our line in that region with an arrow, so that implies positive infinity. So you might find it helpful to do some very light shading maybe with your pencil, or circle negative values and then positive values like I tried to demonstrate.